This problem is called hungry. It says researchers investigated how the size of a bowl affects how much ice cream people tend to scoop when serving themselves. At an ice cream social, people were randomly given either a 17-ounce or a 34-ounce bowl, both large enough that they would not be filled to capacity. They were then invited to scoop as much ice cream as they liked. Did the bowl size change the selected portion size? Here are the summaries. So with the small bowl and then the large bowl, we had 26 people in the small group, 22 in the large bowl group, I should say. The mean was 6.58 ounces of ice cream with a standard deviation of 2.91. And over here, the mean was 5.07, and the standard deviation was 1.84. Now I'm going to call this group 1, and I'm going to call this group 2. So we just want to know if this bowl size changed the portion size. And it says, for assumptions and conditions that you cannot test, you may assume that they are sufficiently satisfied to proceed. So we're just going to assume that our assumptions and conditions are met. And again, those assumptions and conditions are independent, random, 10%, and nearly normal. Nearly normal. And then finally, because we have two groups, independent groups. So we're going to assume that all of these are met. And our test, our null hypothesis, is that there is no difference in the average amount that the two groups serve themselves. So that means the mean amount that group 1 served themselves minus the mean amount of group 2 that served themselves, that the difference between those is 0, and the alternative is that the difference is not 0, okay? And so, under the null hypothesis, our difference would be centered at 0, but what we observe, our observed difference, y1 bar minus y2 bar, is we observe that one group served themselves, the average was 5.07, and the other group, their average was 6.58. So the observed difference is negative 1.51, and we want to know if negative 1.51 is a significant difference or not. And because it's a two-tailed test, we got to also find the probability in the corresponding other side. So under the null hypothesis, this would follow something like a normal distribution, except it's actually the t-distribution because we're using standard deviations as our best guess for sigma. And the standard error is going to be governed by s1 squared over n1 plus s2 squared over n2. So in this case, we have the square root of 1.84 over the size of group 1, 26, plus 2.91 squared over the size of group 2, 22. So that standard error comes out to be get 0.718, and just round off to 0.718. And the degrees of freedom that I have is going to be n1 plus n2 minus 2. So I have 26 plus 22 minus 2. So I have 46 degrees of freedom. Okay, so our t-statistic, we observe the difference to be negative 1.51 minus the mean 0 divided by our standard error, which is 0.718. So our t-statistic ends up being negative 2.103. So negative 2.1. And we're going to look up on our t-table where we have 46 degrees of freedom. So we can't find 46 degrees of freedom, but the closest we can find is 45 degrees of freedom. And we're looking for a t-value of negative 2.1. And again, the t-table only gives us positive values, so we're going to look up positive 2.1. And we see that for 45 degrees of freedom, positive 2.1 is in between this column and this column. It's between 2.01 and 2.41. And we're looking for 2.10. So 2.10 is in between here and here, which means our p-value is in between here and here, the corresponding column heads, for one-tail probability. So we're between 0.025 and 0.01. Oh, I'm sorry, for two-tail probability, we're looking at a two-tail test because it's not equal to. So our p-value, again, we're between 2.01 and 2.41. So our two-tail probability is between 0.05 and 0.02 because it's a two-tailed probability. So our p-value is between 0.05 and 0.02. Okay, if alpha is equal to 0.05, our p-value is still smaller than 0.05 because it's between 0.05 and 0.02. And if our alpha is 0.05, our p-value is smaller than that. So that means we reject the null, and we have evidence that bowl size makes a difference. Okay.